All right, guys, we're back here, 13.3. We're going to talk a little bit about the unit circle. Might want to have one of the PowerPoints we'll get to kind of show you, get familiar with that. Normally I'd have you a printout, but you'll have to refer back to this PowerPoint a little bit as you're getting some practice with this on the worksheets. But, we measured degrees for radians, and for an angle measure we did, degrees. Radian is another way of doing it. It's a unit of measure. It's based on the arc length, and basically it's the angle that gives you the arc length that is the same as the radius. And so we call that a radian. Now, if you kind of think about it, it kind of makes sense then that the number of radians, we know it's 360 degrees to go around in a circle. Well, it kind of makes sense then that if you go all the way around, well, that's the circumference, that's 2 pi radians. So again, that's how you get that. And then so 180 would be pi radians. Okay, so again, the radians kind of think of it as measuring a length. So if you go around and around and around, it's a way to measure how far you've gone as opposed to how many degrees you've spun around. So it's kind of a different way of measuring as we get used to that. So we're going to get used to that. And there's conversions here. Again, it's going to be multiplying to get degrees to radians. We're going to multiply by pi over 180. To get from radians to degrees, we're going to multiply by 180 over pi. Let me show you a couple examples on how to do that. So here's the degrees. So what we do is we'd multiply the degrees times pi over 180. Well, that just gives you negative 60 pi over 180. And then you can always simplify here by dividing those. Obviously, 60 goes into 183 times. So negative pi over 3 would be your radian measure for that same degree. Now we can do it the other way too. If we have 2 pi over 3 radians, well, multiply by 180 over pi. Well, what we get here is 360 pi over 3 pi. Well, the pi is chunga chunga, and 3 goes into 360 120 times, so 120 degrees. So that's a way to convert as we go from one to the other. All right, so again, how do you tell if it's degrees or radians? Well, degree will usually have the degree symbol. Radians don't, and usually have a pi with included. So here we go, 80 degrees. Converting that to radians, we would multiply by pi over 180. So 80 pi over 180, you can reduce that, obviously. You can cut those down to 4 ninths. 4 ninths is what you can do there. All right, 2 pi over 9 radians, converting that to degrees, we multiply by 180 over pi. So we get 360 pi over 9 pi. The pi's cancel off. 9 goes into 360 40 times. So 40 degrees would be our measure there. Okay, so again, you have this little thing over here, a little reminder, keep that out. That's something that's nice to have. All right, the next thing we're going to talk about is our friend, the unit circle. Wow, this looks kind of intense here. But what it is it just kind of basically the length for a unit circle. This is where the radius is 1. Okay, so it's a length, 1 unit that we go around. And so to find these different angles here, like at 30 degrees, again, that's going to be pi over 6 radians. So it's kind of nice as you look around here. Here is the degree measures. Here are the radian equivalents to it. And then these would be the coordinates that you'd run into. And it's kind of neat because the sine of that angle, so sine of 30 degrees, would actually be the y value. It's actually 1/2. The cosine is actually the x value. Is kind of nice because we have these color-coded here. You can kind of see that that's a reminder of what it is. Now, again, to get to the tangent, all you have to do is take y and divide it by x. So just take sine divided by cosine, and that's what the tangent will be. Okay, so I'm going to have this over here as a reminder as we're working on a few of these problems, but I think we can get through those pretty easily here. All right, so here we go. So let's say we want to find the cosine of 225 degrees. Well, let's go over here. 225 is right here. Remember, cosine is the x value, so we would say, hey, that's negative root 2 over 2. It's kind of nice. Okay, you can put that in the calculator. Calculator will give you a decimal equivalent to that. But again, this will be a nice little thing. Now, what if we wanted to do the tangent of 5 pi over 6? Well, let's go over here. 5 pi over 6. There it is right there. That's the radian. So they might give it to you in degrees, might give it to you in radians. Now, to find the tangent, we take the sine or the y value, which is 1/2. We're going to divide that by negative root 3 over 2. Now, remember, when we have these fractions, don't divide. Multiply by the reciprocal. Well, then what happens here is we get this. We get the 2's will cancel. And so we'll have negative 1 over root 3. And you might say, well, how do you get to here? Well, remember, if you have negative 1 over root 3, I'll kind of show you that here. Let's get that out there. If you have negative 1 over root 3, All right, remember to rationalize the denominator, we multiply by root 3 over root 3. And so what happens is on top, what happens is that becomes a negative root 3. And then on the bottom, what happens is that just becomes a 3. So that's the simplified. We don't, in these cases, we don't like to leave the radical in the denominator at all. So we got that back. So that's how you do those. All right, let's go to another one. How about the sine of 315 degrees? So let's go over here. We see we have 315. Now sine, oh yeah, that's the y value. So that would just be root 2 over 2. All right, let's see if we got another one here. I think we do. What about the tangent of 180? Okay, well, here's 180 right here. All right, well, the sine or the y value is 0, the x value, so we take 0 divided by negative 1, well, which is just 0, is what we get there. Okay, so you'll get some practice, kind of familiar with yourself, that unit circle. Maybe a good idea to have that slide out while you're going through the worksheets and doing everything like that. Now, other things to keep in mind. Kind of this little chart kind of shows you where things are positive and negative. Now remember, sine is really the y value, so it makes sense that the sine will be positive in the first and second quadrant, negative in the third and fourth. Cosine is the x coordinate, so therefore it makes sense that it's going to be positive in the first and fourth, but negative in the second and third. And tangent, of course, is sine divided by cosine, so when they're the same, it'll be positive. And when they're opposite, obviously when you take positive divided by negative or vice versa, you're going to get negatives in those things. So it's a good thing to keep in mind as you do those. All right, so let's look at a couple problems here. Use a reference angle. So what we can do is go back to our unit circle, find the sine, cosine, and tangent of 330. So if we go here, there's 330. Well, there's the sine, negative 1/2. There's the cosine, root 3 over 2. Now remember, to get the tangent, we got to take sine divided by cosine, or y divided by x. Well, look what happens again here. What I do is change this, multiply by the reciprocal, so 2 over root 3. Same thing that happened before. Remember what we had? We had negative 1 over root 3, but multiply by root 3 over root 3 to rationalize that denominator, and you'll have your better answer right there. All right. Now, what would happen here if, let's say that we had 270. Okay, well, there we go. There's 270. Well, the sine, that's easy. That's negative 1. The cosine is 0. Well, look what happens here when I take sine divided by cosine, or y divided by x. Negative 1 divided by 0, that's undefined. You can't do that. So there isn't actually a tangent. And if you try to put that in the calculator, it would say error is what it would say. Now, there's one other thing we're going to talk about. It's a way to find the arc length, and it's kind of based on the fact that, well, whatever fraction of the circle you're talking about, so whatever your measurement in radians is, we know all the way around the circle is 2 pi, so it's that fraction. Well, that's the same thing as the arc length divided by the circumference. So by simplifying this, we get kind of a neat little formula here. What we're going to end up getting if we cross multiply and then solve, obviously, we can see here that theta is actually going to be s divided by r. And then, of course, if we do some manipulation here, we can swing that over. To find an arc length, okay, all you have to know is the radius and the central angle. So in a little picture here, here it is. To find this arc length here, just take this angle. Now again, that angle has to be in radians. That's the benefit of using radians, because it's a length. And we can multiply that by the radius. That will give you this length right here. And again, you'll have a problem or two that you'll have to kind of work that on. So make sure you have that. Okay, well, that takes care of 13.3. Introduction, hopefully get comfortable using that unit circle. Have that slide out. Again, come email me and see me if there's any questions. Good luck with that. Until next time, I'm Mr. Boone.